Students, good morning. Good morning to one and all. So this is your ninth class of your first module, that is Introduction to Kinematics of Machines. Let me begin with today's class, and today's topic is degrees of freedom. Okay, just take the heading as degrees of freedom, and you can call this degrees of freedom as mobility of mechanism also. Mobility of mechanism. Please take this heading, and I'll let in some other students also. I think this screen is visible, this degrees of freedom.
Yes, sir.
Okay. We are going to solve some problems on degrees of freedom in this today's class. Please take this heading, that is degrees of freedom or mobility of mechanism. So let me explain what is exactly this degrees of freedom with help of some animations. First, let me show this ceiling fan. Okay. So how many independent motion this ceiling fan have? Can anybody? What are the type of motions a ceiling fan can have? Anyone?
Motion.
Okay. It can only have a rotary motion. Okay. About z axis. If you're going to consider this axis as a z axis, it can only rotate. It cannot move up and down. It cannot move left and right. So I can say that degrees of freedom of this ceiling fan is 1. It means the number of independent motion that a body can have. So that is nothing but this degrees of freedom. Okay. And one more example, you can take this one, rocket. Okay. So how many motions that a rocket can have? Means number of restricted motions you can see. Anyone?
One.
Okay. One more answer. Any more answers? Can you see it is moving in upward direction? Means it is having one linear motion and it is rotating about a z axis. Okay. It means I can say that it is restricted to move in two different directions. One is along a vertical direction in a upward way, and one more is it can rotate about the z axis. So I can say that number of degrees of freedom that a rocket can have is 2. Okay, even though it can move towards left and right, but this rocket is restricted to move in only upward direction, and it can rotate freely about its z-axis or its own axis. Okay, so one linear motion and one more rotary motion this rocket can have. So I can call the mobility of a mechanism or mobility of this rocket or degrees of freedom of this rocket as 2. And what about this car? So what is the degrees of freedom of a car? Just wait for a second. Yeah. Can anyone? What is the degrees of freedom of a car or any automobile? Anyone? So I can give a hint that it is restricted to rotate or move in only on a single plane. You can say on the earth. Okay, it cannot move on the space. Okay, so whether this animation is visible, this car animation, anyone?
Yes, sir.
Okay, then can guess no what is the independent motion that a car can have. So you can see a car can move front and back. Correct, you can see it can have one linear motion along one axis. Okay, and it can rotate about the z axis. Okay, if you're going to consider three axes, that is x, y, z. Okay, it can move either in x or either in y, not at a time. Okay, and it can rotate about the z axis. Okay, so I can say that the degrees of freedom of a vehicle, which is restricted to move on only earth, okay, not on the space. Okay, so is 2. One linear motion, it may be a front and back, and one more is rotary motion about the z-axis. Okay, suddenly it cannot move either towards left and right suddenly. Okay, it has to take a turn, then it can move. Okay, so finally I'll consider this aeroplane. Anyone, anyone just guess the number of degrees of freedom that an aeroplane can have? Anyone just guess? Any guesses? So better I can explain the degrees of freedom of this aeroplane as a 6. So I'll explain how it is. Okay, you can consider this as an aeroplane. Okay, and this is the x-axis, this is the y-axis, and this is z-axis. Okay, so the aeroplane is free to move in a x direction. Okay, the front direction you can say, and it can move along y-axis also. Okay, by varying a drag and lift of this aeroplane, it can have a linear motion along this y-axis also, and one more is it can move up and down also. It can move in up and down direction also. You can see during a takeoff. Okay, so it is moving in upward direction. So suddenly it can move in a vertical direction, that is you can see along the z-axis. It means the aeroplane has 3 linear motions along x, along y, and along z. Okay, and one more is so with the help of different actuators, okay, which are fixed at the back side and at the this side wings, so it can roll. It can roll about the x-axis also. Okay, it can roll by 5 degree, 10 degree with the help of the actuators about this x-axis. Okay, it means one rotary path. One more is it can rotate about z also. It can rotate about z also by varying the drag and lift of this vertical stabilizer. Can see this one. So it can rotate also about the z-axis. So you can see the direction. And one more is during the takeoff and landing time. So the nose may be up or nose may be down. It means it can roll about the y-axis also. You can say a pitching action of this aeroplane about y-axis. Okay, it can move up and down. Okay, so finally the degrees of freedom of an aeroplane is 6. 3 linear, that is along x, y, z, and 3 rotary. One is about x-axis, one more about y-axis, one more about z-axis. Okay, so you can take any body which is on the space. Okay, so it will be having a 6 degrees of freedom maximum. 3 linear along x, y, z, and 3 rotary motions about x, about y, about z. Okay, so how can you define degrees of freedom of any mechanism or any body? It means it is a number of independent motions that body can have. That is nothing but degrees of freedom. And let me show one more example. Yeah, just consider a kinematic link, whether this PDF is visible. This PDF is visible or not? Please let me know.
Yes,
Yes, sir, it's visible.
Okay, so just consider this as a rectangular bar AB. Okay, which is having some length. Okay, and I want to find out the degrees of freedom of this kinematic link. Okay, so for example, so if it is present in the first quadrant, okay, this is x-axis, y-axis, and this is present in the first quadrant. Okay, I want to locate the exact position of this kinematic link. When you consider this point A, I can locate the coordinates, that is x coordinate from this reference O, and a y coordinate from again the same reference. Okay, so I can locate the exact position of this kinematic link at point A by specifying x coordinate and y coordinate. And one more is, just wait for a second, someone wants to, yeah, so I was explaining at least two coordinates are required to specify the location of this point A. And one more is this link either can be in a 0 degree or 90 degree, 180, or between 0 and 90. Okay, it means one more coordinate is required, that is angular displacement of this kinematic link. Okay, totally two linear coordinates and one rotary coordinates are required to specify the exact position of this kinematic link. So I can say degrees of freedom of this kinematic link, which is present on a plane of paper, okay, not in the space, is 3. For example, if I want to locate your location of your exact your home, okay, I want to know the exact location of your home from Jain College of Engineering. For example, if you're going to consider this reference as the Jain College of Engineering, okay, and this is your home, I want to locate the exact position of your home from this Jain College of Engineering. Okay, for that I need the distance along the x-axis and a distance along the y-axis. Okay, and one more is I want one more information that whether your house is facing towards east direction or west direction, north or south. Okay, it means I need at least 3 coordinates so that I can locate the exact position of your home. Okay, either it is facing towards east, west, north, and north or south. Okay, that is one coordinate, and two more are this horizontal distance and vertical distance from this JCE. Okay, so one more way of defining the degrees of freedom is number of independent variables which are required to define the exact condition, exact situation, or exact position of this body, this kinematic link. Okay, let's take the definition. Degrees of freedom is defined as the number of independent variables that must be specified to define the complete condition of the system. If you want to imagine what is the exact condition of this kinematic link, at least you need to specify these 3 coordinates. One is x, one is y, one more is the angular position, that is theta. Okay, so the degrees of freedom of this kinematic link is 3. And I explained this also. A body can have maximum 6 degrees of freedom. 3 linear along x-axis, along y-axis, along z-axis, and 3 rotary about x-axis, about y-axis, and about z-axis. Okay, so we can mention those as the 3 translational motions along x, y, z, and the 3 rotary motions about x, y, z. If you want, you can mention the angle also. Okay, so this is about the degrees of freedom. I hope this is clear. Any doubts, please let me know. If it is clear, you can say yes. Otherwise, no. Anyone?
Yes,
Please.
sir.
Okay. In that case, directly I'll go to the problems. So before that, for any mechanism, it may be a 4-bar, it may be a single slider, double slider. I want to find the degrees of freedom. Okay, theoretically, not practically. So for that, there is one formula that is cut-batch criterion, you can say, which is used to find the degrees of freedom of any mechanism. Okay, so please note down this formula. Okay, this is the equation is cut-batch criterion. Please write down this equation. N is equal to 3L minus 1 minus 2J minus H. Whether this equation is visible? Yeah. N is equal to 3L minus 1 minus 2J minus H. Just wait for a second. So this equation is used to find the degrees of freedom of any mechanism. Okay, and can say the small letter n as the degrees of freedom of the mechanism. L is number of kinematic links which are present in that mechanism. Okay, L is number of links or kinematic links. J is the number of binary joints, or you can say number of lower pairs. Lower pair means between two kinematic links, the type of contact should be surface contact. Remember. Okay. Either it may be a lower pace or number of joints, number of binary joints. Just underline this word, number of binary joints. Okay. If at any particular joint, if there are only two links are joining, so such joint is called as binary. And this H is number of higher pairs. Higher pair means between two kinematic links, the type of contact will be either point contact or line contact. Remember, lower pair means surface contact, higher pair means point or line contact. In shortcut, you can remember as HP, HPL. H for higher page, P means point contact, L means line contact. HPL for this higher page. Whether you have noted down this equation, shall I go to the next page? Anyone from 4th A division? Have you noted down this equation?
Yes, sir.
Yes, sir.
Okay. What about Nitin? Shall I move to the next page? Yeah. Let's take the next one more criteria, that is the Grubler's criteria. Just take the heading Grubler's criteria. It's also very simple. If I am going to modify this equation, it will become a Grubler's criteria. The modification is, I'll put n is equal to 1. The above equation, that is equation 1, just substitute the number of degrees of freedom as 1 and higher pairs as 0. Just take this condition, degrees of freedom is equal to 1 and number of higher pairs as 0. So after simplification, you will get this equation. So this equation number 2 is known as the Grubler's criterion. It is used for only the mechanism which is having a single degrees of freedom, and the type of contact between all the links is only lower pairs. There is no higher pair. That's why H is 0. Okay. Just substitute n is equal to 1 and H is equal to 0. After simplification, you'll get this equation, that is 3L minus 2J, okay, minus 4 is equal to 0. Yeah, so this equation. So in that case, you can take this note also. If you are getting the degrees of freedom as 0, n is equal to 0. So such type of mechanism is known as a locked chain. It means there will not be any motion. There will not be any input motion and there is no output motion. So when degrees of freedom n is equal to 0, so such type of mechanism is known as locked chain. And if you are getting the answer as 1, n is equal to 1, or degrees of freedom as 1, and such type of mechanism is known as constrained motion, constrained mechanism. Constrained means it is restricted to only one direction. Okay, it is free to rotate, or it is free to move in only one direction. Example is your ceiling fan, which is restricted to rotate in only one direction. Okay, about z-axis. Means degrees of freedom is 1, means the type of mechanism is constrained. If the degrees of freedom is 2, n is equal to 2. Okay, n is equal to 2. Such type of motion is known as the incompletely constrained motion. Means at least two variables are required to specify the condition of that mechanism. Okay, n is equal to 0, n is equal to 1, and n is equal to 2. This is a locked chain, this is a constrained chain, and this is a incompletely constrained. So then in the tomorrow's class, I'll explain what is exactly incompletely constrained motion. Okay, just don't worry about that. You just take this note: n is equal to 0, n is equal to 1, and n is equal to 2. And one more is if n becomes minus 1, if the degrees of freedom becomes minus 1, okay, Such type of mechanism is known as indeterminate structure. It means by using this Grubler's or this Goodbatch equation, it is not possible to find the degrees of freedom of that mechanism. Such structure is known as indeterminate structure when n becomes -1. Okay, so 4 types of values you may get. More than this also you'll get, but minimum n is equal to 0, n is equal to 1, n is equal to 2, and n may be -1. Okay. If that is clear, I'll start with this first numerical first problem on this degrees of freedom. Okay, just take the heading, determine the mobility or degrees of freedom of the mechanism given below. I hope this first numerical is visible. Just draw a rough diagram of this one. Okay, so you can say this is a kinematic group of so many kinematic links. I want to find the degrees of freedom. Just try to get the degrees of freedom using that equation. First write this equation, that is n is equal to 3l minus 1 minus 2j minus h. Just take this equation. Yeah. So in this figure you can see there are 3 links. First link is this one. This is the first kinematic link or element. So I'll give the namings, that is 1, and this AC is a third link, and this BC is a second link. First, second, and 3. It means L is equal to 3. And what about J? Number of joints. I want number of joints also. Between the first kinematic link and the second kinematic link, there is one joint, and I can call this joint as a binary joint because at this joint only there are 2 kinematic links. They are joining at the same point. Okay. At this joint B, there are 2 kinematic links are converging. So such a joint is known as binary. If there are 3 kinematic links are joining at the same point, so I can call such joint as ternary. If there are 4 kinematic links are joining at the same point, so I can call such joint as quaternary. But in this case, you can see between the first kinematic link, that is 1 and 2, there is one binary joint. So again between 2 and 3, there is one more binary joint. Again between 3 and 1, there is one more. So J is equal to 3, number of binary joints. And this is only a symbol. Okay, in actual case, all the kinematic links will be in the form of a rectangular bar, a circular bar, anything. Okay, the shape may not be like a straight line. It may be of any shape. Okay, for your convenience, I'm showing this symbol, that is a line diagram. So if you are to consider the type of kinematic link is rectangular, here also rectangular, and the type of pair means the type of contact is a surface contact. Okay, this also a rectangular bar, and this also rectangular bar. The type of contact, just remember the word, the type of contact is surface contact. It means there is no line or point contact. It means if there is no line or point contact, I can say the number of higher pairs, h is equal to 0. H is equal to 0. There is no point or line contact between each kinematic link. Okay, the type of contact between all the links is surface contact. It means it can have 3 lower pairs. There is no point contact, so h is 0. So whether you are getting n is equal to 0 after substituting this value of L, J, and H, after simplification, whether you are getting this value, anyone, your feedback is important. Otherwise, I'll not get any reply from your side. At least say whether
Sir, about
H is nothing but this is a higher pair. Just if you want, just wait for a second, because in the previous class I explain what is exactly a higher pair. Just wait for a second.
So explain diagram.
Okay, just wait. So you can see this higher pair. No? Higher pair means between two kinematic links, the type of contact will be either line or point. Okay, you can see between this ball bearing and this inner racing, the type of contact is point contact. Here also point contact, but here between the roller bearing and this inner ring, the type of contact is line. Here also you can see the type of contact is point. Again, between the wheels of the bicycle with respect to the earth, the type of contact is point. Between gears also the type of contact is point. So these type of contacts are known as higher pairs. And if the type of contact between two kinematic links is type of in the form of a surface contact, okay, the surface of one kinematic link and surface of another kinematic link, they're making one pair. The such type of contact is known as lower pair. You can see all these are examples of lower pair. Just remember the word surface contact. You can see the type of contact between two kinematic links is surface, then I can call such pair as lower. And if the type of contact between two kinematic links, either it will be a point or line, I can say such kind of pair as higher pair. Okay, so actually it is not a single straight line, but in actual case it will be in the form of a rectangular bar. Okay, it means one rectangular bar and one more rectangular bar, and the type of contact is surface, not the point. There is no ball bearing, there is no roller bearing, there is no gear. Okay, so the type of contact between this kinematic link and this is surface contact. So there is no line or point contact, so H is 0. H means number of higher pairs. Okay, so after substituting these values, I got the degrees of freedom as 0. It means, as I said, this is a locked chain. You can try in your home also. Just
Sir, what is the L?
L is number of kinematic links. So this is one kinematic link, this is one more, this is one more. AB, BC, and AC. Can consider there
And
are
the
three.
sir J.
Pardon me. J is
J, yes, sir, J. What?
J is a joint.
So,
Okay, so the type of joint between two kinematic links. You can see kinematic link 1 and 2, they are joined by pin joint. You can consider as a nut and bolt joint. Okay, so that there will be a relative motion in other cases. Between one first kinematic link, you can see this one, and between second kinematic link, what is the type of joint? Okay, so this is a binary joint. This is also one more, this is also one more. Between first and second, there is one joint. Between second and third, there is one more. Between third and one, there is one more. J means number of binary joints. Okay, just take down this. After solving some more problems, you'll get exactly what is LJH. Okay, rating the degrees of freedom as 0. Rating the degrees of freedom as 0. It means, as I explained, this triangular form of a kinematic chain, it will form a log chain. In your home, you can try this. Just consider 3 wooden sticks and join all the 3 sticks. Okay, try to move that. You just try to give the input motion at this link 2. The link 3 will not move. Okay, because it forms a structure as I explained in the previous classes. Okay, this triangular kinematic chain, it forms a structure. There will not be any relative motion between any link. It means the degrees of freedom is 0. There is no motion at all. Okay, just take the second one. So after solving 2 to 3 problems, you'll get the exact idea what is LJH. Just consider this second mechanism, that is a 4-bar mechanism. Just draw this. So this second problem is nothing but a 4-bar mechanism, and it is having 4 kinematic links. Link AB is one kinematic link, BC is the second one, CD is the third one, and DA is fourth kinematic links. L means the number of kinematic links are 4. And what about J? Number of binary joints. Okay. The first kinematic link and the second one, they are joining at certain point. That is point B. And the type of joint is binary because only there are 2 kinematic links are joining at this place. Between 1 and 2 there is one joint. Between 2 and 3 there is one more joint. Okay. Between 3 and 4 there is one more. Between 4 and 1 there is one more. Total number of joints are 4. And the type of contact between each link, it will be a surface contact. Okay. So it means there is no point or line contact between each kinematic links. So the type of pair is higher pair. Sorry, there is no higher pair. It means S is 0. So I'll solve some problems where there is a point or line contact. The mechanism which is having a higher pairs. So then only can compare what is exactly lower and higher pair. Okay. For the time being, we just take S as 0. There is no point or line contact between each kinematic link. This is a line diagram. This is not an exact diagram. Okay. Physically, this link 1, it may be in the form of a rectangle of any shape, it may be a triangle, any shape. Okay. Type of contact between each link is a surface contact, not the point. Hence, H is 0. There is no point contact. H is 0. Whether you are getting degrees of freedom as 1, anyone? Anyone, please let me know. We are getting degrees of freedom as 1 or not. It means if you are giving input
Yes,
at
sir.
Yes, sir.
if you are giving input at second link, okay, it can move only from left to right and right to left. Okay. If you want the animation, I can show the animation.
Yes, sir.
I can see this 4-bar chain. Okay. So it is moving in only one direction. It means
Yes, sir.
if you're going to specify the angle theta at the input, for
One, sir.
example,
Yes, sir.
if you're going to mention the angle theta, for example, 0 degree or 90 degree, it will be,
Sir, one more, sir.
yeah, you'll be able to locate the exact position of this kinematic link. For example, now you can see the angle is approximately 100 degree. Okay, if you're going to mention one angle, so I can imagine what is the exact position of this. Okay, if it is 90 degree, I can imagine what is the position. If it is 180, okay, as I said, it is a number of the variables that are required to specify the exact position of this kinetic chain. Okay, and okay, then I'll go to the next one. Just take this one.
Sir, your idea is not clear.
Once again. Please pardon me, I'm not getting your words. Just wait for a second, there is a network problem. Okay, please let me know now the screen is visible, because there was a problem with the internet. Yeah, whether this problem is visible now?
Yes, sir.
Okay. In that case, please take the next
Yes,
one. Okay, just take this third numerical, that is this one. Just take a rough diagram of this one. A group of 5 kinematic links. Group of 5 kinematic links. Yeah. So this mechanism is having 5 kinematic links. That is, AB is one kinematic link, BC is one more. Just write down the numbers. This number indicates kinematic links. Okay, and these alphabets indicates joints. First kinematic link, BC is the second one, CD is the third one, and DE is the fourth one, and finally this EA is the fifth one. Number of kinematic links are 5, and between the first kinematic link, that is AB and BC, at point B, you can see the type of joint is a binary, because only 2 kinematic links are meeting at this point. The type of joint at point B is binary. Again, between 2 and 3, there is one more. Between 3 and 4, there is one more. Between 4 and 5, one more. Between 5 and 1, there is one more. Total number of binary joints are 5. J is equal to 5. And there is no point contact between each links. So there is no point contact means there is no higher pair. H is 0. H means number of higher pairs. Just tell me the answer. What is the degrees of freedom? Just substitute all the values.
to 2.
Okay, 2. Correct. It means at least you need two coordinates. Okay, for example, at least you have to mention this angle. Okay, theta 1. Okay, and you need to mention this also. So at least you need two coordinates, then only you can locate the exact position of this one. Okay. Okay, you need to mention this angle and this, then only you can locate the exact position. You can imagine what is the exact position of this mechanism. But in the previous case, if you are going to mention only one angle, this one, so you can imagine what is the position of other links. Okay, all are interrelated. So that is the only meaning, that is n is equal to 2 means at least two coordinates are required to explain the status or the condition of this mechanism. That is n is equal to 2. And I'll take a simple example to get a clear idea. I'll take one more example. Yeah, just take this one, problem number 6. I'll take another 5 minutes. Just take this figure so that I can explain what is exactly this higher pair. So you can take this as a support or a frame which is fixed as kinematic link 1. To this frame, there is one more link is attached at this point. So this is the second kinematic link, and this is the third kinematic link. So this third kinematic link is attached to a circular wheel or a disc at this point 4. Okay, and the type of joint is a binary, or it is a rotary joint. It means the wheel is free to rotate. Okay, it is in the bracket. It is mentioned that it is rolling as well as sliding. It means the wheel is free to rotate at this point 4 with respect to kinematic link 3. It means number of kinematic links are 4. The fixed one is 1. You can take this as a crank, this as a connecting rod, and this is a circular disc. Totally 4 kinematic links. L is 4. Now how to find the joints? Between this fixed link, that is 1 and 2, there is one joint. Between 2 and 3, there is one more. Between 3 and 4, because this link 3 is attached with this link 4 at this point. Okay, the type of joint is binary, and you can see there is no joint between this fixed frame and this circular disc. Okay, there's only a contact is there. There is no joint. There is no nut and bolt. There is no pin and joint. Simply wheel is the wheel is placed around this platform. There is no joint at all. Just remember, the word contact is different and the word joint is different. So this is a joint, this is also joint, this is also joint. But here it is a contact. Okay, the circular wheel is in contact with this link 1, but there is no joint. So I can say the number of joints are 3. Between 1 and 2, there is one joint. Between 2 and 3, one more. Between 3 and 4, there is one more. Number of joints are 3. Okay. And what about between first link and the fourth link? So there is a contact. So what is the type of contact? It is a point contact because the type of link is a circular one. So the type of contact between the first link and the fourth link is at this point. It is a point contact. Point contact means, remember, it is a higher pair. Higher pair.
Higher pair.
Okay. H is 1. Okay. Instead of a wheel, if there is a piston, if there is a slider, so I can say the type of contact is a surface contact, as in case of this one. You can see if there's a piston, the type of contact will be surface. Then in that case, there is no H. H is 0. Okay. But since in this case, the type of the fourth link is a wheel, so I can say the type of contact between the frame and the wheel is a point contact. So it means H is 1. Just substitute the value. That is L is equal to 4, J is equal to 3, and H is 1. You get the answer as 2 degrees of freedom.
Yes, sir.
Okay. It means at least 2 coordinates are required to specify the exact position of this mechanism. One is this θ1, and you need to mention the angle of this wheel. Just take any one as the reference. What is the angular position of this wheel? Okay, 2 coordinates are required to specify the exact condition of this mechanism. Okay, just take this as a reference x. Okay, what is the angle made by this circular disc? Whether it is at a 0 degree, 90, 360. Okay, and one more, this the angle made by this crank with respect to the frame. Okay, this angle and this angle. So that is nothing but this degrees of freedom. So I'll take the last problem so that I can clarify what is the exactly surface and point contact. Just take this one, 8th problem, which is nothing but your IC engine. Okay, this will be a crankshaft, this is a crank, this is a connecting rod, and this is a piston. Okay, and this will be your cylinder. Okay, the cylinder will be fixed, correct? There's no movement of the cylinder. So this and this and this, all fixed links are considered as only one link. Okay, all fixed links are considered as only one link. Now I can say I can
So
start.
H equal to 1. N
Yeah.
equal to 1.
Okay, correct.
N equal to 1.
Correct. The degrees of freedom is 1. Means if you're going to mention this angle, crank angle, θ1, okay, that is sufficient to locate the exact position of this piston, crank, connecting rod. N is 1. Okay, so if you want the explanation, okay, so this crank is one kinematic link. Okay, but in actual case, the crank will not be in a straight line. So as I explained in the PPT, so in the first slide, the kinematic link. Okay, actually this is a where it is. This is a crank. You can see at the bottom portion. So this is a crank, but I've shown with a line diagram. So this is a connecting rod, and this is your cylinder, and this is a piston. They're not in a you can say they're not a straight line. They're not a single line. Okay, but for our convenience, while drawing, we'll show with a line diagram. Okay, so don't confuse with why it is this is also line, this is also line, and the type of contact is a point. Not. Actually, the crank will be like this, and the connecting rod will be like this, and the type of contact will be a surface contact. Okay, So, and can see there are 4 kinematic links. That is a crank, first one, connecting rod, second, the piston is the third one, and this the fixed link is nothing but a cylinder. The cylinder will be fixed. So I can consider that as 4. Okay, this is also 4. Fixed link is considered as only one link. For example, if you're in your home, there are 4 ceiling fans. Okay, the roof is only one, but the fans are attached to the same ceiling. Okay, where maybe you are having one fan in your bedroom and one fan in a hall. Okay, it means the roof is only one. Okay, the fixed link is only one. Okay, at different places the links are attached. Okay, and the joint J is equal to 4. How? Between the first and fourth link there is one joint. Between first and second there is one more. Between second and third, between connecting rod and this piston there is one joint. Okay, 3. Okay, and between 3 and 4 the type of contact will be a surface contact because the piston is going to slide. Okay, the surface of the piston and the surface of the cylinder, they are in contact, and the type of contact is surface contact. Okay, so as I said, J is nothing but number of binary joints plus number of lower pairs. Remember, okay, in the J itself binary joints also comes and lower pairs also comes. So you have 3 binary joints between 1 and 4, between 1 and 2, between 2 and 3. Okay, 3 plus, and the type of contact between the 3 and 4 is a surface, that is a lower pair. Surface contact means lower pair. It comes here itself. 3 plus 1 is 4. So total J is 4. And there is no point contact between any link. There is no line contact at all. H is 0. The higher pair is 0. So after that we'll get N as 1. Okay. So this is what about the degrees of freedom of different mechanisms. If it is clear, in the next class I'll solve some more numericals so that I can clarify if any doubts, okay, in the degrees of freedom. So if it is clear, I'll wind up today's class. Okay, thank you.